Let's look at this example for center of mass between two curves. So let's go through it. So find the center of mass of the region bounded by 6 minus x squared and 3 minus 2x. Make a little note here. I mentioned before, but I'm doing it again here. If rho is constants, we say that the center of mass is a centroid. So it doesn't really have to do with the mass, really. It's kind of like the general location of a balance point. Anyway, okay. So go ahead and sketch the graph. You should get. And I'm going to do a rough sketch, and then I have it written. I have it already written out. So the rough sketch, you have a parabola that opens down like this, and another graph coming in like this. Actually, I think it's more like this. So it intersects, and then this is the area in question, like that. Then you need to find the intersection points, right, to figure out where to integrate from where to where, and then calculate everything we just did above. All right, so let me erase that, and then I'll paste in the graphs. And I also set them equal and solved. So set equal and solve, and figure out the picture. Okay, so here it is. Okay, so here's the picture of everything. So we have 6 minus x squared is the parabola, like that, up 6 units, opens down. The 3 minus 2x, slope of negative 2x, up 3 units, looks like that. And then to figure out the intersections, you of course set equal and solve. So here's my set equal. And I get 3 and negative 1. You don't really need the y values, but you kind of should get the y values. So you can use, this is off a little bit, but that's okay. So I did find them. Okay, then I went ahead and did the mass here. Then we'll do the rest together. Or you could work ahead, obviously, and try to finish it on your own. Okay, so the mass, we're going to integrate from negative 1 to 3. So negative 1 to 3, and then it's rho, and then it's the difference of the top one minus the bottom. So in that interval, we have parabola is a larger one, and you take the difference, and you're getting that representative rectangle here, and you get the mass when you multiply by rho, because rho is area mass density. Okay, so we will calculate that. Next, let's just go ahead and do that. So let's multiply that out, simplify it, see what you get. So this is equal to negative 1 to 3. Usually we'll factor out the rho. Go ahead and multiply that out and simplify. You should get something like 3 plus 2x minus x squared dx. Okay, and then evaluate that. You get rho. Then that's going to be 3x plus x squared minus 1/3 x cubed from negative 1 to 3. So you get rho, then 3 times 3, so you will work this all out. 9 minus 27/3 minus negative 3 plus 1 plus 1/3 equal to rho 9 minus negative 2 plus 1/3. So it's rho 9 plus 5/3, which equals 32/3 rho. And you can see that in the end, when you do your x bar, your rows always cancel out when rho is constant. So it doesn't really matter that it's there when you have a constant density. Okay, so now do moment about your x. So moment about the x, we will use these formulas above. So moment about x, probably use this guy right here. We already know f and g, and that it's always bigger than g. F is always bigger than g, so we just apply it to this, substitute in, etc. Okay, so usually I like to, I'll write out the formula as we go. So it's 1/2 rho integral, and it's from a to b. F of x squared minus g of x squared dx. Okay, so it's 1/2 rho, and then we integrate. What was it from again? Negative 1 to 3. And now we can substitute in. So this is going to be 6 minus x squared quantity minus 3 minus 2x squared dx, and then multiply all that out. So I will go ahead and I'll skip a step. So multiply all this out. So it's 1/2 rho integral from negative 1 to 3. And I get x to the 4th minus 16x squared plus 12x plus 27 dx equal to 1/2 rho negative 1 to 3. And oops, now I'm evaluating. Duh. Okay, so evaluate. You get what? 1/5 x to the 5th, etc. So you get 1/5 x to the 5th minus 16/3 x cubed. It was all just polynomial stuff. Pretty easy to do, just kind of tedious, right? 27x negative 1 to 3. All right, I have the rest all worked out. So you just substitute and subtract. So here, let's just do that. I'll just paste it over. So just so we have it all together in one spot, huh? Let's see if I can copy all this over. All right, so there you go. Something like this, you know, I don't mind if you check this stuff. Obviously, often when I ask these questions in a regular test, I just ask for setup, or maybe just calculate mass and then just what's the setup kind of thing. Just an FYI, I mean, that's just kind of how I'll do things. Because this stuff from here down, I mean, that's just tedious stuff. I'm not, you know, I kind of assume you can do all that. That's the sort of thing you need to practice in your homework, though. I mean, you have to get good at that. But it's not something that's real critical to your actual thinking and how to do calculus. Okay, next, moment about the y. Let's go ahead and bring it down here. Let's go and do your setup. So moment about y is rho integral from a to b. And then this is just your distance x, and then you have your f of x minus g of x, as your area, and then dx is your thickness. And so that's usually a little easier to calculate. Always depends on the question. This is all, again, polynomial stuff, so not too bad. And then so you have 6 minus x squared minus 3 minus 2x dx. So multiply all that out, simplify it, you get rho integral -1 to 3. And then multiply it out, I'll simplify it. I'll skip one step. See if you get this polynomial. And then now integrate. So when you integrate, you get -1/4 x to the 4th, 2/3 x to the 3rd, plus 3/2 x squared. So at this stage, you should be pretty comfortable with just cranking out those integrals. You shouldn't really have to think much how to do that. You shouldn't be using the formula. You should just know how to get it. If you're not, then you need to practice more, because it should be just easy. Add, divide, add, divide, add, divide. Just boom, boom, boom like that. Okay, now you substitute and solve. And you get rho, and then it's -1/4, 3 to the 4th, 2/3 3 squared, 3/2 3 squared, minus quantity, and then you're changing signs if it's odd power and not if it's even power, because it's the -1. And you work that out and you get 32/3 rho. So x bar is moment, and this is always confusing, but it's moment about the y over mass, which is 32/3 rho over, and it ends up being the same thing for some weird reason. So x bar is 1, y bar is not 1. Moment about x over mass is 416/15 rho over 32/3 rho. Ends up being 13/5, which is approximately, well, it actually is 2.6. So your centroid is 1/13/5, or 1 and 2.6. So if you look at the graph I did earlier, I actually put in that point kind of ahead of time because I was plotting it. I wanted to see what it looked like. Did it make sense for that to be the right point? And so if you look at the graph, if you look at just the shape of that, does that make sense? Right about here, right? You go over 1, and then you go up 1, 2, and it's like 2.6. That roughly makes sense. I mean, that's it's not maybe clear. I would think it'd be maybe right here, but my graph's not perfect. So I think this actually goes down farther, which would make, so then you get more stuff down here. So that's roughly correct. Like if you got it way up here, you know it's wrong, right? That can't be the center of mass up here, unless you had varying density. Then it's hard to tell. But since the density is the same, and if this was like a metal plate, you'd be able to that's essentially where you'd be able to balance it right there. That's the concept. Okay, that finishes up chapter 6. We'll move on to chapter 7, which is on transcendental functions and some fun stuff in there.